From the Asgard Company Studios in beautiful Wichita Falls, Texas, from the finest mind in the modern fitness industry, the one true voice in the strength and conditioning profession, the most important podcast on the internet. Ladies and gentlemen, starting Strength Radio. Welcome back to Starting Strength Radio. We are, as usual, here on Friday. And this particular Friday, we were in search of a more interesting topic than dealing with your bullshit questions like we did past couple of times. And, you know, your questions are at times interesting, but we have, you know, I think we've got higher standards than that, don't you? Rusty, you think that?
Oh, yeah.
I mean, we can do better than that. We can do better than
just answering
Q&A
people's questions.
bullshit.
The same questions over and over again.
Same questions over and over again.
Yeah.
We can do better than that. So this time we're going to do better than that. One of our favorite shows, one of the shows that we got the most compliments on is the one where we talked with our friend Scott Davison about what the hell did we talk about?
We call it B-52s in the Cold War.
B-52s in the Cold War, something like that. So, you know, Scott came up to the gym last night, and he and I were sitting around shooting the shit, and we said, well, hell, you know, we could talk about all kinds of interesting stuff. So tonight, we're going to kind of reprise that first show, and we're going to talk about airplanes and weapons. Airplanes and weapons. Every guy's favorite topic.
Nothing's more fun.
Nothing's more fun than airplanes and weapons. So the girls are probably all saying to themselves, you know, let's go watch An Incredible Lightness of Being again, you know. And the guys are all going, yeah, airplanes and weapons. So I understand the girls are bailing, but we don't have they don't comprise a huge percentage of the audience anyway, and that's just the way the demographics of our shit here works, you know. When was the last time, in fact, that we had more than 5 women at the seminar? Oh, it's been a long time, isn't it? It's been a long time. We usually have 2 or 3 girls at the seminar, and then the rest of them are guys. So
and they're being dragged in by their significant others.
Right. Yeah, they didn't want to be there, but they showed up anyway. We have every once in a while we'll have 6, maybe 7 girls. Like once every 3 years we'll do something like that. But these topics that we deal with are typically, you know, male kind of things, and that's not our fault. I mean, it's not like we keep women from signing up, is it? Have you ever had somebody try to sign up and you had to say, no, you're a girl? Bree's never turned a girl away from the seminar. It's just, you know, this kind of shit we do. It's just
or in her private life, I'm sure.
It's just kind of male. Well, I didn't want to get into that, but if you, so here we are. I mean, this is kind of like a seminar kind of thing. You know, it's mainly guy stuff. And if girls don't like that, you know, I tell you what we'll do. We'll have a podcast one time on the incredible lightness of being. Will that satisfy everybody? Or would you girls be happy with that if we did it?
Hey, there might be a couple of them that are really into B-52s.
Hey, there's female B-52 crew members now.
How about first seat pilots?
There's some.
There's a few.
Yeah.
I mean, somebody's got to fly the damn things.
That's it.
Right? And if the Pentagon wants it to be girls, then girls fly the damn things. Well, let's talk about the damn things. You'll start with weapons or airplanes? Let's do airplanes first.
All right.
Since airplanes deliver weapons.
So what do you want to know?
Well, really, an airplane is a weapon, isn't it?
A military airplane, a combat airplane.
A combat airplane is actually technically the same thing as a rifle.
We call them weapon systems.
Right.
So B-52 weapon system,
Right.
F-16 weapon system.
So the B-52 weapons system is comprised of the airplane, the crew, and the ordnance,
Yep,
and that all comprises the weapons system,
I would say so. Yep.
right? So who is in charge of this system?
The job title is crew commander
Right.
back in my day, or pilot, the guy in the left seat. On all airplanes except helicopters, the guy in the left seat is the senior pilot.
Right.
So in my day, when we had crews were always stuck together, the job was called crew commander. And you addressed each other on the interphone by what seat you're sitting in.
Mm-hmm.
So if you put the navigator in the IP seat to give him some experience, when you talk to him, you call him co-pilot, or IP, even though he's a navigator.
Mm-hmm.
So
Okay. Yeah, well, everybody knows who they're listening to and talking.
yeah, you're talking to the seat.
Ah,
On the interphone, you're talking to
the
the
seat is the job.
Whoever's in it. Yeah.
Right.
Because on interphone, you got to be careful you communicate properly.
Mm-hmm.
You don't do things. You don't say the word fire unless you mean it.
Right.
You don't discuss. Hey, maybe we should bail out. Somebody's going to misconstrue that and pull the ejection
and
in.
bailed the fuck out.
Yeah. So
No joking around.
not certain words.
Scott, has that happened before?
The one I know of was there was a gunner who went to sleep on climb out. And on initial level off, the co-pilot was flying the airplane. And the pilot could see that he was going to overshoot the level off. He was going to climb through his assigned altitude. So he waited for him. And when the co-pilot indeed went through the altitude, the pilot in the left seat started yelling at him, "Level out, level out, level out." Well, they zero-G'd the airplane. The gunner woke up with somebody screaming "out" on the interphone.
Oh, no.
So he did.
Oh my God!
He did. Yeah. But it was,
I wonder how he explained that later.
Oh yeah, I mean,
I'm sorry, I was asleep.
Yeah.
How the tail gunner in a
and you call back-
B-52 fall asleep?
He probably didn't.
That
have
was
to
a
explain
tired
it.
motherfucker.
They just probably booted him right out.
I really don't know what the aftermath was on that. But,
Oh, God almighty.
but I always thought about how do you report back to the command post on this? We have a change to our flight orders. Got a different list of people. Took off with one more than we're going to land with.
That's not supposed to be the case. Is it? Oh shit! So, the B-52. What an interesting aircraft. We talked about the B-52 last time, but this fascinating device was developed in the early 1950s.
Yep.
And I think the oldest airframe, or the newest airframe in the inventory right now, was built in what, 68?
I think it was 61.
61.
Early 60s. No later than 62.
And we're still flying this airplane 60
Sure.
years later.
Sure, because it still does stuff that no other airplane can do.
Isn't that just amazing?
Yeah, I mean,
It's just absolutely amazing. There are a few aircraft that have been developed by the air forces of the world and the aerospace companies of the world, and the B-52 and the C-47
KC-135.
I mean, you can't do without those.
KC-135.
KC-135.
You can't overstate the importance of the KC-135 and air refueling in general.
Right.
The U.S. Air Force is almost universally air refuelable. Almost everybody does it. And during the Cold War, that gave us capabilities that other countries couldn't even think about.
Nobody else had that kind of capability.
They didn't have the massive capability that we had. Virtually everybody's refuelable now.
Right.
The tankers are refuelable. Not the KC-135s, but the KC-10s are, and the new tankers, which I can't remember the designation. So the guys who pass fuel also receive fuel.
So if you're flying a KC-10, who can you refuel? Smaller aircraft, right?
Or another KC-10.
Or another KC-10.
Or a B-52.
Right.
You can refuel almost anybody.
A 10 can.
Yes. The real question is, what kind of equipment does the receiver have?
Mm-hmm.
Okay. Most planes now are being designed so that they refuel with a boom. So the boom operator in the back of the tanker flies the hose into the receptacle in the receiver.
Mm-hmm.
Okay. But some airplanes, helicopters, for instance, they use what's called probe and drogue. So on the receiving airplane, there's some sort of pipe that sticks way out, and then
Right.
the tanker just deploys a loose hose with an umbrella-shaped thing on the end,
To stabilize it,
Right.
flying through the air.
and then the
right?
receiver pilot has to plug that.
Stab that in,
Yeah.
right?
Yeah. If you're boom refueling, when I was refueling B-52s, I'd just get myself into a position underneath the tanker, and the boom operator flies the fuel
He
into
stabs it into the plane.
Right,
Right.
right. I just fly
But
position.
in the other configuration, it's the receiver.
receiver's got to find that probe,
responsible
that
for-
drogue, and stick that probe in there. Yeah. Mm-hmm. So helicopters have to be that way, obviously, because you
Right.
get that rotor.
So, yeah, we talked about air refueling last time, and it's a fascinating topic. Who thought that up? What lunatic thought that let's fill another airplane up all the way to the top with gas?
Some of these great pioneers after World War II came up with this idea. You know, the very first air refueling was done. Two planes just flew in vertical formation, and they literally dropped a hose down to the other guy, who put it into their normal ground refueling receptacle, and they pumped fuel. They proved the concept. These are both biplanes. I could
Right.
give you a year somewhere. In there.
Oh, this is a long.
This is
ass
1920s.
time ago. Oh God.
Yeah.
Right.
But of course, it wasn't a routine thing at the time. They just
Right.
proved the concept that it was possible.
Right.
It was again the Cold War that really provided the impetus to get this really going and get everybody doing this.
Mm-hmm.
You know, I've seen. I don't know. I'm sure if you look on the internet, you can find them. But at the basic B-52 school back when I went, they had a hallway that was dedicated to photographs of air refueling incidents. You know, stuff that went wrong.
Okay.
And some of that you just go,
It makes you not want to.
yeah, I mean, some of that, how does that even happen? You know, I remember seeing a picture of one that had a boom from a KC-135 stuck through the engine pod of a B-52, like an arrow shot through it. How do you miss the thing by that much? I mean, just don't.
There's a bump in the air.
Yeah, I get, but that would take a
I
big
don't
bump.
understand how any of this is done anyway. I mean,
you really
is
have
the
to-
air that calm at 38,000 feet?
Generally, it is. But you just have to. It doesn't matter. You just gotta fight through it. You need the fuel. You know, you just gotta.
So if you got IFR going on, and you're flying through clouds, and you are relying only on instruments, and there is turbulence and weather, it doesn't matter.
you go.
You have to refuel.
What might happen is you might get disconnected a few times because you just can't stay in position because of the turbulence. But yeah, I refueled at night in the weather more times than I can count.
Right.
So it's time to refuel. You do it. You know.
Well, I guess you've got no other option, do you?
Yeah. Well, we use on training sorties in the B-52.
Well, a training sortie, you can turn around and go home. But if you're
Right.
not, if you're actually on a mission someplace,
Yeah.
you
You got to get it. You need the
gotta
fuel to
get
get the
the
mission
fuel.
done. You do it. You know.
right.
What choice do you have? So, but it's
terribly
indescribably difficult to do. It's
It's
most difficult thing I've ever done in my
indescribably
whole life.
difficult to. I still have no idea what the hell you guys do to make that happen. I can imagine flying in a straight line, all right, and I can imagine everything. You know, you got gigantic surfaces in contact with a huge amount of air, flying through clear air, and everything's fairly stable, right? But how big a bump can that hooked up apparatus actually tolerate?
well, on a KC-135, we had to keep our refueling receptacle in a 4-foot cube space, 4 feet on each side. If we got outside that, it would automatically disconnect us.
So it disconnects and a valve closes so it doesn't spray fuel all over
Yeah,
it.
there's a little bit of spray comes out of the tanker, but it's just a little
Right.
mist.
Right.
And you can see that if you look at videos of air refueling when they disconnect, you'll see that little.
But there's not 8 or 9 pounds of fuel sprayed all over
No.
it. So it's a pretty good little disconnect system.
Yeah, and now it's a really mature system.
Oh, I'm sure it is.
Decades of learning how to do all this.
Right.
You know, and it's gotten pretty reliable. Although we did have one airplane during Desert Storm that he had a malfunction on the receiver and he couldn't get his fuel, so he had to abort the mission and divert to another place. It was a pre-strike refueling, and it was I don't remember what the malfunction was in the receiver, but there was something wrong with it.
Something wrong with it. But
It could happen.
So if you leave the base in North Dakota, and you're on a mission that lasts 20 hours. That's typical, right?
I mean, that's typical. That's on the long side. 12-hour training sorties were typical, and now they're shorter. They don't go on low-level routes anymore, for instance. And we used to spend up to 4 hours on low level. So that's just been subtracted from the missions now, I gather.
Really?
Yeah.
They use different aircraft for that now?
They going low level is really hard on the structure of a B-52. And
I can imagine.
they did it for decades, and it got to where it's just not smart to do anymore. It's too much fatigue.
Because of the
yeah,
buffeting it takes, because
constant.
of the
When you're
ground,
low,
the
yeah.
topography doing things.
When you're low, there's always turbulence, always.
Right.
And plus the way the controls work, it makes the wings flex a lot. They're designed to flex quite a bit.
Right.
But all of that still induces metal fatigue.
Right. They're 60 years old.
Right.
Let's not flex them any more than we need to. How about
Exactly.
that?
Yeah.
Right. So in a course of a 12-hour training sortie, how many times you going to fuel?
Once.
That'd be once.
But you're going to be on that boom for 45 minutes an hour, maybe more.
To fill the airplane back up.
Yeah, in training sorties we didn't fill up. We didn't need the fuel. We needed the practice.
Right. Oh, you just top it off.
Yeah, we'd
Just
take
for run it through the procedure.
Yeah, we'd take maybe 10,000 pounds, which to us is nothing.
So if you're going, say, from Minot, North Dakota, over the top of the Arctic and down the eastern coast of Asia to the Philippines, and you're gonna destroy Manila, right? And then you're gonna fly back to Minot, North Dakota. How many times do you fuel in that kind of an insane? But that's a typical deal, right?
Yeah. I mean, that's a typical contingency type thought. Yeah.
Right.
Well, again, there's a lot of variation depending on are you going to go low level, how high are you going to be,
Right.
What's the payload you got. But I would say typically you'd probably need 3 or 4 tankers from that.
So you'd hook up 3 or 4 times
Yeah. During Desert Storm.
for an hour at a time.
Yeah. As long as it takes to get the fuel, and that might be an hour, yeah. Because we could not take, if the tanker turned on all his pumps, it was more pressure than our manifold could take. So there had to be a little patience in there,
Right. And run it at 65% or something.
Well, I'll give you an example. During Desert Storm again, my unit was deployed to RAF Fairford in central England. And every day we flew combat sorties all the way to Iraq and back to England. So the short ones were 17 hours long. And they required 1 tanker prior to the target and 2 tankers to get back. And this is B-52s versus KC-135 tankers.
Right.
So I'm trying to remember. Tanker could offload to us. He had a max gross weight of about 275,000, of which probably 200,000 was fuel he could pass. I'm really stretching my memory here. So, it might take. You might take on a total load of 400,000 or 500,000 pounds in the route. The thing burns massive amounts of fuel.
Yeah.
We had a canned figure that it took us 4,000 pounds to start the engines and get to the runway.
Just to move the aircraft into position to take off.
Yeah, you put 8 of those old technology engines, start running fuel through them, they're gonna eat a lot of fuel, and they burn.
Yeah,
dirty.
I think we talked last time about the design of the B-52. The whole damn thing is a tank.
Yeah.
The entire internal volume of the wing is full of liquid fuel.
Right, and the top of the fuselage spine is all liquid fuel.
It's all liquid fuel. Everywhere in the fuselage that's not bombs is fuel.
Bombers, since they were invented in World War I, have been fuel trucks, because range and payload is what you need.
Right.
So they're all fuel trucks.
Right.
3/4. Let's see, we had a max gross weight peacetime 488,000 pounds, of which I think about 315,000 could be fuel. So that's 75% of your weight, something like that.
75% of the weight of the payload, or the weight of the
Total gross weight of the
gross
airplane.
weight of the airplane.
Yeah,
Is 75% of
rough, give or take.
Yeah.
Could be
That might be added to that might be replenished 3 times
maybe
during the course of the.
But that's what gave it its fantastic legs. You know, we used to fly these in the Cold War days. We would fly these over open ocean, hunt down the Soviet ship missions, and those might be 20-hour missions. Might require 3 tankers, but most of it was at high altitude. So more fuel efficient at high altitude.
40,000 feet.
Usually not that high, 30 to 35.
Right.
Something like that.
About airliner cruising.
Yeah, the
altitude.
airliners like that 35 to 40.
Right.
For fuel efficiency. But of course, out over the open ocean, we're not on a flight plan or anything. We're not in bombers.
Right.
We'd either file a false flight plan or we wouldn't file anyone at all, because the flight plan systems are open computers at the.
Yeah,
the
you didn't
Soviets
want
could hack,
anybody to. Steph was showing me last night a website. Apparently, there are 2 or 3 websites right now. Have you seen these things? Where all the airplanes in the air at any given time
Oh yeah.
appear on the on the screen.
ADSBexchange.com. Yeah, it's a fascinating website. I've spent hours looking at that.
ADSBexchange.com.
Yeah. And you can click on any of the targets, and it'll give you all the information it has
About the
on it.
airplane. Yeah,
You know,
that's what she showed me last
You can
night.
isolate just military planes. You know,
Yeah.
some of which won't tell you what kind of plane they are because they're
XXX.
because
right, shows
it's
up.
not public information.
Right.
So yeah, I've spent hours on that website.
Yeah, that's pretty cool. And I didn't know of its existence till she showed me last night.
Yeah, that's a great website.
She also told me last night that her grandfather flew B-17s in World War II. Now, those guys, that's a whole different
I can't.
approach to killing people and breaking things.
I can't imagine that job.
It's the aircraft itself has not got a pressurized cockpit.
No.
So at 10,000 feet or 12,000 feet, what was the actual service ceiling of that silly thing? 14, 15,000 feet?
Oh, I think a little higher, maybe 20. I don't know. But
How do you function at 20,000 feet for any length of time?
the crew, particularly the waist gunners, had electric suits to wear. They were like an electric
Because
blanket.
it's 80 million degrees below zero up there, you know, and it's and there's not any air. I can see how they covered them up in sheepskin and stuff.
Oh,
And
yeah.
they kept them kind of warm with clothes, but after a while, the absence of enough air to breathe.
Well, they had to
it's
provide
just-
something on oxygen. They had
How
oxygen
did they
masks.
do that back then?
Kind of like they do now. They had oxygen tanks, and it was plumbing running through the airplane. And
Right.
you could plug your oxygen mask into a port, kind of.
So you actually had access to O2.
Oh, you have to. Yeah. Above 14,000 feet, you need supplemental oxygen.
Yeah.
So for most planes, they'll provide it above 10,000 for some safety margin. And it's all about your time of useful consciousness, they call it.
Yeah. I've heard that concept. But those guys, hell, those B-17 crews, what was the average
Yeah, the
lifespan of those guys? Was
Less
like
than
8 missions?
less than 50% was your life expectancy for every single mission.
Yeah. That's why
the longest living guy flew 15 missions or something like that?
well, it got better. But
The
the reason the Memphis Belle is so famous is because it took like a year or year and a half for one B-17 crew to fly 25 missions and no fatalities. That's why that plane was so famous. And at that time, that was your quota. If you flew 25 missions and were alive, you could go home. And that was the odds were against you.
Right. Right.
So, I can't imagine that. I can't imagine the morale problems they had in those squadrons.
Can you imagine loading up on your 8th or 9th mission in a B-17 and thinking to yourself, everybody I know is dead.
Yeah.
And
Everybody
the
I've
average-
ever known, all the guys I trained with have been shot down, and here's my ass,
And the average age was
getting on this airplane.
less than 25. So less than 25.
Yeah, all those pilots were kids.
Yeah. I can't imagine being a B-17 pilot because your combat mission is you're going to take off, you're going to be in the middle of a cloud of maybe hundreds of airplanes. And your only job is to not have a mid-air collision with the other airplanes. You can't look out the window and worry about the fighters or the aircraft fire or anything. You just got to not have a mid-air collision.
With one of your own
for hours on
squadron.
end. Yeah.
Right.
And this is going to be 5-6 hour combat mission, and you've got anti-aircraft fire and fighters trying to kill you.
And really the least of your concerns is dropping the bombs on the target.
The pilot had no concern with that at all. That was the navigators did that. The pilot's job was to not have a mid-air collision. That was his job. I can't imagine it. It's beyond my scope. The bomber job I did was so different. We were almost always single ship, It was just me and my 5 guys. And there's no other airplane for me to worry about, So I just can't imagine it. Bombing is a completely different job than it was in 1944.
When those guys would send B-17s, like you're going to go make another run over Leipzig, how many are in the squad?
Well, it all depends on what was available, and what the target was. And
5 or 6 or 15 or 20?
No, a squadron would be 20, 25, something like that. So you would launch wings, okay?
Right.
Wings have multiple squadrons. So a lot of the race, especially as the war went on, they launched multiple wings. There might be 500 B-17s attacking that target today. And this was necessary because, by the way, despite its name of
100 airplanes.
And despite
in the air altogether.
Yeah. But the reason why is because despite the name of precision daylight bombing, they estimated that maybe 10 or 12% of the bombs would hit in the target box. So you had to send a lot of airplanes to make sure enough bombs got in the target box.
To actually fuck the thing up that was to be destroyed that day.
Yeah.
Well, that is interesting. We were talking the other night about the precision of bombing now. And you told me that you guys operated from 40,000 feet, and you could put 750-pound bombs on top of a target, a relatively small target, from that altitude, and that it was normal for you to be able to not miss with any one of the bombs.
It was common.
Now that's a whole different thing.
Yeah, it wasn't.
What changed from 1944?
Technology. Hell, it changed. My first B-52 sortie was in 1976, and we couldn't bomb like that then. Right?
Could not.
No.
What were you doing then?
After you dropped a single simulated nuke from 40,000 feet, you were thrilled if it hit within 4,000 or 5,000 feet of the target. And right. For nukes, that might be okay, depending on the nuke and the target.
Right.
But by the time
close is okay with nukes and hand grenades and shit fights.
Right.
But I mean, a 4,000 or 5,000 foot radius of effectiveness still gives you the ability to be effective against that target. Right.
It should be, yeah.
Right. And that got better.
Technology, computers changed everything, man. Digital stuff. When the computer we were using to bomb with in 1976 was an analog thing full of vacuum tubes and relays. You could actually stand inside that computer. And the good navigator teams were the ones that could get it to work. I'm not exaggerating.
They could get the equipment to operate.
The radar navigator, who you would call bombardier, would board the plane with a great big suitcase full of vacuum tubes and relays and stuff.
In case he needed it.
Yeah. And it was very common to spend your high-altitude cruise time after the tanker before low level. The radar navigator standing inside the computer, and the navigator's trying to, and they're talking on the interphone, shake that one, kick that one, replace that one, trying to get stuff to work. It was really common those days. Solid state and transistors and digital changed all of that.
Right.
Everything became plug in a new one, and it works.
Right.
Take it out and we'll give it to maintenance when we get back. They'll put it on a bench and figure it out. But we got to replace it. We'll plug it in.
Right.
Plus the accuracy, just all this computing power.
Mm-hmm.
Remember 1976, there wasn't a desktop computer.
No,
they didn't exist yet.
For another, 8 or 9 years.
Yeah, there was programmable calculators. That's the best you could get. You know? And so the digital revolution just changed all this stuff. So much computing power now. You know, when I graduated from college in 1974, the University of Minnesota had a computer, and it filled a 3-story building. You know, and it was 1/1000th as powerful as your cell phone.
Right.
So think of that.
Right.
Think of what that
I remember
revolution
the
has
computer
done.
room in a little college I went to here in town. It filled up a large room, and it was punch cards.
Oh yeah,
Was the interface. Punch cards was the interface, and they held class on that old equipment.
oh yeah.
And every year, the class that you had taken last year was irrelevant.
Yeah.
You had to take another one.
Because it's changed.
Right.
Yeah.
But I suppose that at 40,000 feet, the things that are going to enable you to drop a bomb out of an aircraft and hit a target on the ground while you are flying at 500 miles an hour are going to be, if you can get that data into the computer, you get the temperature and the wind speed and all of the weather between the bomb bay and the ground, and the airspeed and the precise location of the target, that can all be calculated, and you can let the computer drop the bomb, and the damn thing goes where it's supposed
Right.
to. So that's the object, right?
Yeah, and remember, so far we talked about unguided weapons. Gravity is the only force pulling that bomb down.
Right.
A larger and larger percentage of everything the U.S. does, and much of the West, is guided weapons. So there's a computer on the weapon that's changing its path, you know. And,
Right.
those get spectacularly accurate, you know.
In response to changing conditions or in response to changes in the destination of the weapon.
Yeah, changes in the target, that's pretty new, and there's still not, as far as what I know that's out there in the general public, that's still not a fully developed thing. But there are weapons. I just read something on the internet about how there's weapons in the testing stage that the idea is the bomber's going to drop the weapon, and it's going to find the target.
It's going to decide what it's going to.
It changes
So
priorities.
it'll have orders coming from somebody besides the airplane that dropped
Right,
it.
it's pre-programmed with priorities. So
Right.
when I dropped it, I wanted it to hit target A. As it fell, it decided that target B is a higher priority, and so it changed its course. That's pretty new technology.
Right.
You know, but guiding them to the targets you had when you released the weapon, that's been around since Vietnam. Laser-guided bombs were first used in Vietnam.
Right.
So they would just ride the laser beam down, you know.
Well, that's kind of what the forward controller does, right?
He can, you know. That's another one of those really gets into what your specifics you're talking about. But yeah, there's forward air controllers are
The
used with most.
CCI guy.
Most Army units have one associated with them, and usually it's an Air Force guy, usually a fighter pilot.
Those guys are not really talked about very much.
Yeah.
The CCI, the combat control.
Combat control team. Yeah, they're pretty hush hush.
That's not discussed very much, and those are the craziest bastards in the world.
Those are snake eaters, those guys. But they're well respected. Okay.
I'd have to say that they are. Because that job is, you have to be absolutely crazy. Because 100% of that job is takes place behind enemy lines.
Yep, that's their function.
And
I don't know the details, and nobody told me, but I guarantee you.
Essentially, they're going and painting an X on the door and saying, kill these guys. But they got to go physically paint the X on the door.
Yeah. Or at least get a laser on them, you know. But yeah, nobody told me, so I'm not divulging anything here. But I promise you that before we launched our first air raid during Desert Storm, that those guys have been on the ground for a long time.
Now, by a long time, you mean a couple of days? Or
days to weeks.
Days to weeks.
Yeah.
They'd been crawling around on the ground, finding targets.
Gathering intel, reporting the weather, you know.
This is behind enemy lines where the bombs were going to drop.
Yeah. They go, when you get selected to do this out of boot camp, you're almost 2 years away from getting qualified. They go to school after school after school. It's just, God almighty. Because they're qualified. They're meteorologists, they're radio operators, they're radar controllers, they're infantrymen. You know.
They're in charge of a whole bunch of information.
Yeah, yeah.
They've been prepared very, very thoroughly.
And they can all do one or two other guys' jobs in case somebody's a casualty.
Right. And
they're smart.
they're,
Absolutely.
They're highly intelligent,
Yep.
and they don't worry about things that you and I worry about.
Yeah. Yeah.
Like getting bit by bugs.
Yeah.
Just not a factor.
No, you have to lay there and be quiet.
Lay there and be quiet. Doesn't matter what's happening to you. You lay there and be quiet.
Survival might depend on it. So
More importantly than that, the mission.
Right. So there's a bee sting in your forehead. You have to just sit there.
Yeah.
Not for me, thanks.
Yeah, it's a different type of human being that wants to do that. I've met a couple of those guys over the past 20 years, and you have to have a lot of respect for that kind of focus.
You talk about physical fitness,
Oh, well, that's not even. It's beyond that.
It's not a job I'd want to do.
No, that doesn't sound like. It's not a job that not everybody.
No, and if you volunteer for it, it's not to get patted on the back, because nobody's ever going to know you did
Nobody's
it.
going to know anything about what you do.
Yeah.
No, I had never heard of this before I met these guys.
I was stationed near one of those combat control teams, because they have some permanent locations around the globe that they'll deploy out of there.
Right.
Usually in parts. So they might have 40 guys there, but only 10-man teams might deploy something.
Mm-hmm.
The year I was near those guys, they did halo jumps for training, high altitude, low opening.
Right.
And they'll jump out of a plane at an altitude that requires oxygen, so they're way up there.
Yeah.
And then they just free fall.
And the point of that is they want to drop out of the airplane, and somebody on the ground might be able to see the aircraft, but they would not ever associate that aircraft with somebody jumping out of the damn thing. And then they drop down and open it 800 feet.
The last second, yeah.
The last second.
Got an
800
altimeter
feet,
on their wrist or
boom,
something. And
they're on the ground. No, that was, I read about that, about the halo thing. And it might have been in that book about Area 51.
Yeah, I haven't read this. I don't know.
That is a fascinating book.
Yeah.
I can't remember the girl's name that wrote it.
I can't think of it either.
She's written several books about this kind of shit. She gets an annoying number of things wrong that you can kind of recognize if you know anything at all about this. But
Is it Annie Jacobson?
Annie Jacobson, you look her up.
Well,
Look her.
Sounds
She's
interesting.
but the whole book about Area 51 is a fascinating book. She put some stuff about aliens in there to sell the book, but Area 51 was where they developed aircraft.
right. The only thing I know about is that's where they trained in the F-117s when it was secret.
PS-22, I think they called it, but it was, but Area 51, that whole complex out there, was where they developed the U-2 and the ox cart and the SR-71. That was what the facility was for. And all this other shit was just,
Yeah,
know.
they did an amazingly good job of keeping that stuff classified.
Yeah, they really did. It's what's the ox cart? Why? The CIA's version of the SR-71.
Well, the YF-12.
YF-12. Yes. Yeah. The YF-12. That was a. Now you talk about cool airplanes. Let's go back to airplanes for a while. Everybody's favorite airplane in the whole world is the SR-71. Did you ever know anybody
Oh, yeah, I had a boss
that flew that airplane?
Yeah, I had an 06, a full colonel boss that flew the SR-71. And, of course, in those days, it was still flying, so he couldn't talk a lot about it.
Right.
He did tell me that at the time, I think the Air Force would admit that its speed was in excess of Mach 2. I think that was the official release data. And I asked him about it, and he said, way in excess.
Way in excess of Mach 2.
So they I don't know that they ever truly declassified all the performance figures for that thing. It was amazing. The guys got astronaut wings when they qualified it.
Wow.
Because of the altitudes they flew at. And they flew in an astronaut suit the whole time because they're. And he did tell me that when you got above a certain altitude, you weren't really flying an airplane anymore. And he said the first versions of it.
It's not aerodynamic.
There's not enough air. Yeah.
Right.
And he said the early versions of it were really complicated to fly. And you spent a lot of time, opening nozzles and closing knobs, and because you're not really flying an airplane.
Right.
And then they when computers got better, they changed it to where it flies like an airplane, and so computer does all that stuff, and you still have a stick and rudder and throttles, And he says it became much easier to fly then.
Well, did you see? Well, we lost Chuck Yeager.
Yes.
A few weeks ago, we lost Chuck Yeager. It's just what a guy.
Oh yeah. Yeah.
And there was that video, that big long interview he did, and I know, Rusty, I know you saw that video, didn't you?
I'm not sure if I saw it.
I thought you did. God, where Chuck is just matter of fact talking about, we got the thing up to 85,000 feet, and I can't remember what he's actually flying. This might have been the X1.
Could be.
And he said he got it on up to 85,000 feet, and they wanted to see what the airplane would do, so I took it on up to 125,000 feet. And just real matter of fact, he's saying he took the thing on up to 125,000 feet, and then, he pancakes the thing, and it starts a flat spin upside down.
I did watch this in your office, yeah.
But just just matter of fact, he says we took it on up to 125,000 feet. The disclosed ceiling of that airplane was 50,000 feet, and he's talking about Mach 4.2.
Yeah. Well,
this is way before the SR-71. Way faster. Who knows what?
There's an often told story in the Air Force about a SR-71. Their call sign was always Blackbird.
Right.
And there's a story, and I'm sure there's.
You're talking about the story where they're out in the western United States and they wanted a speed reading.
No, that's a good one too.
That's a good one.
But no, this one is. It goes something like this. He calls up. He's coming back into the United States, so he calls up an Air Route Traffic Control Center. And he requests flight level 600, which is essentially 60,000 feet.
60,000.
Right. And the controller comes back and says, copy, if you can get up there, you can have it. And he says, Blackbird 1-2 will descend and maintain flight level 600. Smart ass.
Will descend and maintain. But I think there's like an audio recording of the exchange between the SR-71 crew and the tower.
Is this the ground speed check one?
This is the ground speed check.
Yeah, I've heard something that alleges to be that. Yeah.
The ground speed check, and you had a 172, requesting a ground speed check from the tower, and it's 215 miles an hour or something like that. And these smart asses flying a
F-18 or something.
F-18. Yeah. Come back and say, tower requested ground speed check. And the guy comes back and says 675 miles an hour notch or whatever the hell it was.
Probably not.
And these guys in the SR-71 are listening in on this thing. The tower, the guy goes back 2,750 miles. Just to embarrass the guys that were fucking with the guy flying the 172. That was a pretty funny story.
And I'm sure
that's on the internet.
I'm sure there's truth in it. Most of those kind of stories, there's at least some grain of truth in it someplace.
Yeah, I'm sure.
Yeah, the guy who was flying the SR-71 is the one that told the story. He said it was some conference he was talking at.
Yeah, I think I listened to at least some of that tape.
Yeah.
Yeah.
Well, we'd also talked about a couple other bombers that bombers are cool.
I agree.
Bombers are cool. Fast bombers are the coolest airplanes in the world, like the B-59.
B-58?
B-58, I'm sorry, the Hustler.
The Hustler, yeah.
That thing was a Delta Wing supersonic bomber, Mach 2, right?
When it was operational, it was the fastest airplane in the world.
Did you know anybody that flew
I
that?
did. I had another boss that flew those, yeah.
What did he say about that?
He said it was not a pilot's airplane, that if you took off with a full load of fuel, and they used to carry a single weapon and fuel in a big pod underneath the belly. So if you took off with that, it took you many miles to get to a safe flying airspeed, because it took forever. It had just enough thrust to accelerate, like 1 knot per mile or something. Just
Really?
Yeah, he said it was scary. Now, once you got the thing up to speed, then it was a much better behaved airplane. But he also
You're
said,
talking about it just didn't behave correctly under the hand while you were accelerating
because it didn't have enough thrust to go fast, yet. You had to, it's how to explain this. You have to get going to a certain speed, any airplane, Piper
Right.
Cherokee. If it gets too slow, it's sloppy on the controls.
Right.
Well, the B-58 had just enough thrust to eventually get to these high speeds.
Right.
If you had a full payload and that big pod underneath it.
I had a car that behaved that way one time.
Yeah.
Goddamn thing didn't wake up till it was 4,000 RPM.
Yeah.
And, 1,800 RPM is like a Volkswagen.
Yeah.
And then you got it up to 4,000, and suddenly, hell, this thing is in fact fast.
Right.
So that it was similar to this.
Also, it
kind
was
of
like that on initial takeoff with that big pod and everything.
Right.
So it was much better if you didn't have that pod.
So the thing was designed to drop a nuclear weapon,
Single weapon, yeah.
a single nuclear weapon.
Yep. Did not have a big internal bomb. I don't think it had any internal bomb bay. I think they carried that pod.
Really?
I think that's right.
No conventional bombs on this.
Not that I know.
Well, that's interesting.
Because it was designed to dash in. The speed was its protection from ground fire. It was just going so fast nobody could track it. That was the concept.
You get the thing up to Mach 2, go over there, drop the bomb, turn around, take how many 1,000 miles it takes to turn around and come home.
Right.
If you can get back.
Yep. He also told me that on the bomb run, at bomb run speeds with all 4 engines at full afterburner, if one of the outboard engines quit, the plane would come apart. So it just wasn't stressed for any kind of side load like that. So he said it was the only airplane he ever flew that when he was scheduled to fly and it came to him and said, "You're canceled, the plane's broke," he was kind of relieved.
I'll
tell you, give me
didn't
an
really
idea.
want to die.
I'll give you the actual figures. 1 out of 4 that were ever built was destroyed in an accident. That's got to be the worst safety record of any combat airplane ever.
1 out of 4.
So he only served for about 10 years. And the Air Force said, it's just...
What replaced it?
The B-52 came along, and the B-52 was already there, but
They just decided that the 58 the mission wasn't
the
necessary.
performance just wasn't worth the losses they were taking and the expense. It was an airplane way ahead of its time,
So this is an airplane that probably would have worked perfectly well with computers.
Yeah.
That we've got now.
Right, and engines with more thrust and stuff.
Right.
You got to remember that just jet engines were really thrust limited until the 70s. That's why the B-52 needed 8 of them, because jet engines just didn't put out a lot of power.
Right.
So they had to put 8 on a B-52. Now, when they put fan jets on the H model B-52, which is the only one left, I've got 700 or 800 hours in H models, and you could do almost anything but initial takeoff on 2 engines as long as it was symmetrical engines.
They were that far ahead.
Yeah, I mean, you didn't routinely do
the
this,
previous turbojets.
Oh yeah. And now again, you didn't routinely do this, and the key was symmetrical power. Right? Initial takeoff at full gross weight, you could usually handle a tailwind even at full gross weight with 2 engines out, depending on the temperature.
Right.
Because that's something we'd figure out on alert. The duty co-pilot would take today's weather, and he would come up with an 876 engine takeoff performance data. And what you do is calculate the maximum tailwind you could take. Because one of the problems in sitting on nuclear alert is there's one primary runway.
Right.
Okay? If you got to use the other one, your launch is going to be much slower because you got to back taxi 2 miles down that runway.
Right.
And so you had to know how much tailwind you could take on the primary runway.
Right.
And my memory is calculate that stuff in those H models at full wartime weight. It was frequent. We could take 10 and 15, maybe 20 knots of tailwind, even with a couple engines out. So
that is amazing.
It's the only B-52 that was overpowered is the H model, the current one. And they're about to get
So
serious.
how many engines are on the H? 6 or 8?
8.
Still 8 because there's 8 points.
And they're getting real serious talking about re-engineing the Buff now. And GE, I think, and Rolls-Royce are in big competition to sell them engines. But I think they're going to put 8 engines on it again. So it's going to be even more.
Why
overpowered.
not?
Yeah.
You know.
And I think, and I'm speculating, but I think when they went to the drawing board to go, how do we redesign it for 4? It was just too much engineering. Let's just put 8 on it. The plane was designed for 8. Let's put 8 on it.
How much more fuel efficient are these new engines?
Oh, new ones compared to the ones that I flew in G models, they're probably 40-50% more fuel. I mean, it's night and day. The Fanjet H models are 15 to 20% more fuel efficient than the previous ones, but that was a first-generation Fanjet engine. They basically just took the J57 engine that was already there, and the first 2 or 3 compressor stages, they extended the blades out to make fans.
And made a Fanjet out of it.
Yeah.
So it's just a minor redesign, but it was enough difference that it worked in a different manner.
Yeah, the outer part of those blades is now act as propellers, too. And so you get kind of the benefits of propellers, which is fast response.
So you get some thrust from the rotating assembly.
Right. Yeah.
And not just thrust from the burning fuel.
Exactly. So the performance actually falls off with altitude more than the G model did.
I guess it would.
Because propellers fall off in performance at altitude.
Right.
Because they can accelerate the air a certain amount, and that's it.
Right.
So as you get higher and higher, it can accelerate less and less.
Right.
But the H model was way more fuel efficient than the G model, and didn't require water injection to boost takeoff thrust. So which is another complicated thing that could malfunction
and weight.
Yeah, you think every fueling's crazy? Water injected takeoffs in a B-52 were I'd say scary, but they weren't quite scary. They were concerning, and we almost always, if the temperature was above 40 degrees Fahrenheit, basically you had to use water injection. And once you initiated that water, all you could do is steer the airplane. You couldn't adjust the thrust anymore, because if you pulled the power back, the water would flame the engine out. So I know of a guy who was killed when he flamed out 8 of them that way on initial takeoff.
All 8 engines flamed.
He was taken off on what we used to call minimum interval takeoff behind another B-52. And when you'd be on the runway simultaneously, and the plan was to stretch the interval to 12 seconds by the time the first guy took off. But you'd start with 0 seconds, and you'd let the guy ahead of you go 12 seconds, and then you'd apply takeoff power. And the guy behind you would wait 12 seconds, and he'd apply takeoff power. Okay? So you'd end up with
that was the max density you could lift off at one right after it.
The idea being to escape the incoming submarine-launched ballistic missiles,
Right.
So it's considered worth the risk. But it was risky. I mean, I never did those. We had to keep currency in them. You had to do one every 6 months or something. I never volunteered to do more than I had to in those things because they're just frightening. And you get airborne into the worst wake turbulence because you're below and behind a great big heavy guy.
Sure.
And the yoke would start going stop to stop just to try to keep the wingtips out of the telephone poles. It was just. When I look back on it, the safety people would never let you do this anymore. But it was the only way to get a maximum weight B-52G model in the air, or earlier model. Mm-hmm. So this guy, he was taken off in a G model behind an H model, which had the Fanjets. And at low altitude, until the water ran out, that G would actually outperform that H. And so he evidently looked up and had a windscreen full of B-52 in front of him and reacted like any pilot in the world would. He reduced the power. Sadly.
And reduced the power.
And that flamed out all 8
the
engines.
fuel, but not the water.
Right. The water just went. It was on or off. That's it. And so it was still on, so when he pulled the power back, flamed out 8 of them. This is near Sacramento, California.
Was there anything he could have done to salvage that?
The only thing he could have done is try to steer out of the way. But every pilot in the world is going to react by reducing the thrust. It's built into you,
Right.
So I can't remember how many guys.
So that system just worked counter to all your intuition as a pilot, basically.
Yeah, the first time I did one, I was a young co-pilot, and I was scared to death. I was used to 6,000-foot takeoff rolls, no matter what the weight is in an H model. And then my unit re-equipped a G model, so all the pilots had to get checked out. And the checkout program is you would watch one from the IP seat, and then the next time you flew, you would sit in your seat and do it. And I'll never forget sitting in that IP seat and watching a 65-second takeoff roll. My eyes are getting bigger and bigger. You know, the runway remaining markers are going by and going by and going by, and I'm like,
And you're still on the ground.
can we get? Start blowing on the windshield. You know, it was frightening. Little did I know that was going to become another day at the office. You know, because I never flew an H model again after that. So it's amazing what you can get used to. You know, air refueling, something you get used. It's just a job. You just do it. When I look back at it, I go, that's the most difficult thing I've ever done in my life. And really frightening to have two big airplanes so close together. You know, the first time you see it,
the whole damn concept is just so crazy to those of us that sit here on the ground. But
there's YouTube videos taken from the bomber cockpit of refueling, and it doesn't do it justice. It doesn't really show you how difficult that is.
Right.
And it's a skill that you just had to. I can count on two fingers the times I took off in a B-52 and did not plug into a tanker. And 9 out of 10 of those, I didn't need the fuel. I needed the experience.
the practice of plugging it. B-47.
Another cool Boeing product.
What a neat airplane that was. They was that a British design?
No, that's a Boeing.
That's a Boeing aircraft,
product,
and the wing chord on that thing was. This is kind of the opposite of a delta wing.
Yep, it's highly swept, but it's fairly thin for this airplane its size.
Right.
You know? And it was always from the time it was on the drawing board. It was considered an interim airplane to get us to the B-52.
Right.
It had tandem seating for the pilots, and the navigator sat kind of below them on a lower deck. It had a tail gun that was remotely controlled by the co-pilot. Right? Radar aimed and remotely controlled by the co-pilot. 6 engines. It was partially acrobatic. The pilot's airplane. The pilots love flying the airplane. It was like a big and slightly slower to maneuver fighter, you know.
Right.
Again, I had a boss, and it might be the same guy that flew B-58s. I can't remember now. That flew B-47s, because there were so many of them that if you're my age, all the senior staff when you got into B-52s had all flown B-47s and some B-58s. They'd all flown those 24-hour airborne alerts with nukes on the airplane. Stopped doing that in the 60s, so I never did that. But the senior officers all had done that kind of stuff, you know. And they were universal. They loved the airplane. It was a really sweet flying airplane.
Right.
The Air Force eventually asked a little too much out of it. They wanted to do toss bombing with it. And toss bombing is a deal where you put positive G's on the airplane, and at just the right place, you release the weapon. And that allows it actually tosses the bomb, and you turn away.
Right.
So you can toss
So there's a trajectory.
Right.
Not just a drop, but you're creating a trajectory for the weapon.
Right, and so you're throwing the bomb over terrain or defenses or something like that. The story I got was Boeing said, don't do that with the B-47. And SAC said, yeah, we'll go ahead. Right. So
We're good.
after a couple of years of this, they had, I don't know how many, but way too frequent examples of the wings coming off the airplane on initial
Just
takeoff.
too much.
Yeah.
Metal fatigue.
And not doing the toss bombing, but on initial takeoff when your distress is at its most.
So the stress was being applied during the toss bombing.
Right.
And the guys were paying for it on takeoff.
Right. So one of the big B-47 squadrons is at MacDill Air Force Base on the Gulf Coast of Florida, just outside Tampa. And after one or two of those went in there, the unofficial slogan became "one a day in Tampa Bay." Because pilots have good
Pilots are cynical bastards, aren't they?
Well, they got good gallows humor.
Yeah.
You know?
Yes. Yeah. One a day in Tampa Bay.
Yeah. So I don't know how many they lost, but more than one. Right. You know, and Boeing kind of said, "We told you, don't do that," because it just really wasn't designed for that. Designed as an extreme high altitude bomber.
Right.
But there's also a trick to the pilots. Teams had to be matched up very carefully, because in order to get landings, the co-pilot had to fly the whole mission in the front seat, because you couldn't change. If you change seats, then for some period of time, nobody's at the controls.
Right.
So if it's time for the co-pilot to get landing currency, he's going to fly in the front seat. And this caused some stress between the pilot and co-pilot teams, and sometimes you had to find another team that could get along better. And so this guy was telling me, he had a really good story about this. They would fly a 3-ship across the Atlantic Ocean to Spain and Portugal to pull nuclear alert back in the early 60s. And they would coast out on the Atlantic coast of Florida, and they'd take a dead reckoning heading to Europe. And
Straight east.
There's no GPS.
Straight east.
Yep, just fly that heading. So they're out in the middle of the Atlantic Ocean, 3-ship. They're outside of UHF radio, and military always uses UHF, ultra-high frequency radios. And they're outside of UHF range of anybody but themselves. And there was a storage bin that the co-pilot had someplace. And the front seat pilot didn't have any extra room like this. So he carried the pilot's lunch in the co-pilot storage bin. This is the way the guy told me the story anyway. And so in this 3-ship, there was a pair of these pilots that were known for not getting along. Right? And so out in the middle of the ocean, obviously intended to be on interphone, but instead on the radio. Because all you got to do is push the wrong button. This happened all the time. You push the wrong button, So the pilot says, "Hey, co-pilot, pass me on lunch." And somebody in the formation heard this and recognized the voice, and without hesitation jumped on their radio and said, "Get it yourself, fuckface," which you can't do. And he said, when they got back from Europe, those guys still weren't talking to each other. Co-pilot go, I don't know how true the story was, but he had me laughing. And I'm sure similar to things happen.
Oh shit! What other airplane was cool back then? The era of the cool airplane was 1950 through 1975.
Yeah,
right?
A lot of what the U.S. Air Force calls the Century Series fighters, the F-100, F-101, F-102. Those are cool airplanes. The designers could make fast airplanes then. The problem was they couldn't make fast airplanes go slow, so they had some unfriendly characteristics if you weren't careful about your airspeed.
Right.
The F-104.
So the T-33 was the trainer version of the
P-80.
That's what they called that.
Yeah, the World War II.
Just basically a World War II fighter with one jet engine and down the fuselage.
I think at the end of World War II, they got 4 or 5 of those to the continent. I don't think they ever saw any combat with them. So that morphed into the T-33 later.
Right.
A really solid basic design. Another one of those.
Not a very big aircraft.
Yeah. And just another one of those planes that the original design was just so good that it just got adapted to all kinds of roles. And
Right. Like F-86.
Yeah. Yeah.
Solid airplane.
Yeah. When I was
swept wing version of a T-33, basically.
Oh, I think there's more than just that.
Right.
It was a much more of a barrel design, wrapped around an engine kind of thing. I actually saw F-86s flying when I was overseas, and there was contractors, civilians flying them, and they were getting paid to tow targets for the F-16s, the F-4s to shoot at. So they let out a drone, not a drone, that's not the right word, a drogue,
right,
on a cable, and then the fighter pilots could make passes trying to shoot at that drogue.
Oh, that sounds safe.
Yeah. But those guys, the civilians that flew them, were really, they were retired Air Force fighter pilots with long hair, back when you couldn't.
Right.
And they were having time in their life,
Oh, I'm sure.
Flying these things around the Pacific to different locations, and they'd fly a sortie a day, go to the club, What a good deal.
Get paid a lot of money.
But in the meantime, you got young fighter pilots shooting at your
right,
your drogue,
your ass, basically. Yeah, that's.
They call it the dart. They shoot at the dart.
The dart. The F-104. Now there's an interesting airplane. That was the thing was not even aerodynamic.
Yeah,
it below 200 miles an hour. It had no glide ratio. But for some reason, air forces around the world liked that airplane and used it up until just like 15, 20 years ago.
I think the Italians were the last users, and I don't think it's been 20 years since they retired them. I could be wrong. But
the Germans used the damn thing.
Oh, yeah, a lot of them. I have friends at work that flew them.
Yeah.
In the German Air Force. The U.S. Air Force quickly named it the Widowmaker
Yeah.
because of those.
Well,
Those-
single engine.
Yeah.
And
No glide ratio.
No glide ratio. The wings would cut you
They literally would.
from the leading edge of the wing was sharp.
Yep. The
Is
crew
that-
chief would. There was guards they'd put on them after.
Right,
you
that's what I heard from you probably because it was just, the thing and the airfoil was kind of like not really an airfoil, wasn't it?
Yeah, I think it was totally symmetrical airfoil, so it had no camber to it.
Right.
It didn't have that usual airflow shape.
Right.
So you get lift by putting angle of attack on it.
Right.
And planes like that, T-38's like that. It's an almost symmetrical airfoil. And so when you and I remember as a student they demoed this. They would put you in 30 or 40 degrees of bank in a T-38, but not use any back pressure on the stick. And so the plane would almost fly straight ahead, just in the bank.
Really?
And if you got a positively cambered airfoil, it'll turn if you just put it in bank because now there's lift going that way.
Right. It's trying to shove you.
Right, but with a symmetrical airfoil, you put it in bank and then you pull the nose across the horizon because you got to get horizontal lift by creating angle of attack that way.
Right. Well, that's interesting. So the F-104 was kind of an extreme version of that.
That's my understanding. Yeah, and it was designed for straight line speed, nothing else.
Right.
Just go fast. And that's why they adapted the first astronaut classes. Flew a special version of it that had a rocket motor in the tail, just above the exhaust from the main motor.
I think that is the aircraft that Yeager was talking
Oh, it could
about.
be.
You know, now that I think about that interview, it might have been the F-104 he was talking about because they added a rocket motor to the thing to let it do this acceleration thing at that altitude.
Yeah,
And
that could be it.
I believe that's the airplane that, and I could be wrong, but
And I did hear that it had terrible spin characteristics that would go flat on you.
that was the incident he was talking about in that interview. It's apparently a very famous thing that happened to him during that, and he was in a flat spin, upside down,
Yeah. Well,
and got out of the thing in one piece. Can you imagine maintaining any kind of orientation upside down in a flat spin?
I'm sure he had to just sit there till they got the denser air, so he could get some.
That's what he did.
respond
He
to
just
it,
wrote it down, and then apparently got it back up and punched out
Yeah.
and survived the damn thing.
Those guys, those test pilots in the 50s are crazy.
Crazy people.
Almost as crazy as the World War I test pilots, Those guys, at the time, there was no science of aerodynamics. The people building airplanes knew the wing had to be in that shape, but they didn't know why. They didn't understand what was going on.
Right.
And so somebody at some point has to walk out to that plane, and the designer or the builder says, I think it'll be all right. Take off and find out.
That's what your job is. My job is to build it. Your job is to fly it.
Yeah. Yeah.
Okay.
If you were killed in an airplane in World War I, it was like 75% chance it was an accident, not combat. Their own plane was way more dangerous to them than the enemy planes were. They were crazy. A lot of the really famous ones, like the Fokker triplane, the Sopwith Camel, had radial engines. And in those days, what that meant was, the cylinders radiated out from the middle.
Right.
But the propeller was fixed to the engine.
Right.
An entire engine
the
spot.
whole engine block rotated with the propeller around the crankshaft.
And that's how they cooled the engine. Right? And that's now think of the torque.
Think of the moment of inertia.
Yeah, 50% of your
around
weight
that.
is out there spinning around out in the front of you. Crazy. And then most of those planes didn't even have a throttle because they did everything at one speed. Right? So you take off at 80 knots, you climbed at 80 knots, you cruised at 80 knots, you maneuvered at 80 knots, you landed at 80 knots. So if you could hear one,
You turned it on, turned it off.
had kill switches, most of them did. And so that's how you descended. So if you could listen to one land, it would go, and you got to time this now to land.
Wow.
Inherently nuts by today's standards.
Yeah.
So, and even as late as World War II, if you were killed in an airplane, it was 50-50. It was an accident. And some of that was the airplane design, again, was just not where it is today. But a lot of it, too, was everybody's training pilots as fast as they can.
Right.
And so they're not screening them as carefully as we do now. And, And so they basically, if you can get in that airplane and survive, you'll get pilot wings. So
Right.
and again,
God,
those planes were enormously complicated to fly by today's standards. Because the pilot had to control the mixture, the propeller pitch, the temperature of the engine, while he's flying an airplane and people are shooting at you. The workload must have been insane in a P-51 or a Messerschmitt 109.
Mm-hmm.
Can't imagine it.
Yeah, flying the airplane was as complicated as fighting the airplane.
Oh yeah, both of those, Spitfire and the Messerschmitt, had a terrible accident rate in training because they had very narrow landing gear, and the thing would ground loop.
Oh, you mean like under?
Yeah, because
the
the wheels retracted outward, so when they were down, they were close together.
Right.
So now you start stomping on the rudder or something, and it's going to ground loop. It's going to get up on a wing and crash.
Yeah.
I've read more than one book by guys who flew those two airplanes, and they talked about the fatalities and training that they had. Is it one mistake? Plus, tail draggers like that are just more complicated to land and take off than tricycle gear airplanes are.
Mm-hmm.
Because usually on takeoff roll, you had to get to a speed and push the stick forward, and you weren't in the air yet. Miscalculate that, prop strikes the ground, and you might survive.
Maybe.
Yeah. So, I just can't imagine what the workload. Like I said, the B-17, staying in formation without an autopilot, just, oh my God, for hours on end. Unbelievable.
Yeah.
And how they did it.
This is just a personal question. Did you ever have to take go pills and stop pills?
No, in SAC, we absolutely never did that.
Really?
Because of the associated nuclear weapons.
Okay.
They were so hard over about that. One of my best buddies was a tanker pilot, and he had really bad acne.
Yeah.
And so they prescribed him tetracycline, pretty common antibiotic.
Yeah.
He was grounded for weeks while they made sure there was no adverse effects. Fighter pilots did.
Well, I remember that famous story in Desert Storm where we had a bunch of American pilots gun down Canadian ground troops, and when they got back, they were blaming it on their go pills because they were so strung out and they thought that they were enemies.
I don't know. I didn't hear that one.
Yeah.
But
because they got court-martialed, and in their court-martial, that was their defense. They had us strung out on these go pills, and because at the time they were mandatory, and then after that they said they weren't mandatory anymore. Yeah.
But because of the nuclear mission, we could not use. The rule was you can take a Tylenol or an aspirin. You can bring nose spray with you on the flight in case you get a sinus or ear block.
Yeah.
But if you use it, you're grounded as soon as you touch down.
No shit.
Yeah.
That's fucking wild.
You have to go get another physical done. They were hard over.
If you had allergies.
You're probably not going to get certified. You're probably not going to pass a flight physical if you have serious allergies. Probably.
Wow.
Yeah, there was concern. Think about all the stuff that we knew, all the classified stuff we knew. There was concerns about getting general anesthesia. And I don't care what was wrong with you, they would not let you go under general anesthesia until a flight surgeon cleared it. Okay.
And there was probably somebody sitting there with you the whole
There's
time.
no doubt in my mind. Yeah.
Right.
So
You
that's
should
how
start
SAC had the
dabbling.
opposite. I was shocked when I found out that fighter pilots were taking go pills because I had never heard of such a thing. Because we just did not do that in the buff. Like you said, you didn't take anything but a Tylenol or an aspirin. If you needed something else, you go to the flight doc.
Bombers drop bombs.
Yep, that's what they do.
Bombers drop bombs, and bombs explode. And the explosion of a bomb fucks things up on the ground. All right? Bombs are interesting devices. I guess we've got conventional weapons and nuclear weapons. All right? Conventional bombs can be of several types, right?
Oh, yeah.
You've got how many different types of bombs, and what are their applications?
You got general purpose bombs, GP bombs. Okay? Those typically 500-pound Mark 82s or 750-pound M117s. The common one that we carried, and they just have blast.
Produce a shockwave,
Right.
that disrupts everything underneath the exploding ordnance.
Right. Now the Mark 82 can be fitted with penetrator caps so allow it to penetrate a certain amount of like reinforced concrete before the detonation occurs.
Right.
They can be fitted with fuses that make it detonate slightly above the ground. It's like an extended fuse that sticks out of the nose, depending on what you want to do to what the kind of target. Right. But they're gravity unguided weapons. Once they leave the bomb, once they leave the bomb bay, they're just going to fall. Right.
Right. So they're oriented straight down, and since they're leaving the airplane at whatever the cruising speed is, 450 miles an hour, there's a trajectory that eventually erodes to vertical, right?
Correct.
How long does it take for that trajectory to erode to vertical?
And I don't remember exactly anymore. Within a minute or so, I think it's basically.
It's all basically just vertical at that point.
I know when we dropped from 40,000 feet, they would travel about 5 miles. So
in front of the 5 miles horizontally along along the axis of.
And so we typically did not
bearing the airplane is assumed when the thing leaves the aircraft.
Right. So we typically did not overfly the target if you're bombing from altitude. You release the weapons, they're on their merry way. You turn.
You get the hell out of there, right? And how long does it take for the bomb to fall from 40,000 feet to the ground?
I want to say a minute and a half, maybe 2 minutes. It takes quite a while. I mean, that's a long way.
Right.
So
because its vertical speed when it leaves the bomb bay is essentially zero, and it has to. And then I guess there's a terminal velocity depending on the aerodynamics of the bomb itself.
Yeah.
Right.
Again, the guys who really knew that kind of information were the navigators.
Right.
Because they were the guys that employed the weapons. They were the weapons experts on a bomber crew in my day. The crew commander was in charge of the mission, and he was the pilot.
Right.
He had a co-pilot because no one guy can fly the airplane all the time. Just can't do it.
Right.
Plus, there's so many controls running that one human being can't reach all of the stuff.
Right.
So that's why you need two. And the co-pilot, he's in training to be a crew commander.
Right.
And then you got a navigator downstairs who, on a well-oiled crew, gets you from takeoff to what's called the initial point, the last turn point before the target. And at that point, he turns it over to the bombardier, which in B-52s we call the radar navigator. He conducts the bomb run.
So the navigator and the radar navigator are two different guys.
Yep. They sit down on the lower deck. The radar navigator is the senior of the two guys. Okay? Right. The guy in the right seat, the navigator, is an apprentice to become a radar navigator. And they're really the central part of the mission.
Right.
That navigator, that junior navigator, initiated most of the operational checklists and when I first got in the buffs, worked really hard because there wasn't inertial navigation systems and GPSs, and he sat down there with a plotter and a board and
did a bunch of math problems.
Yeah, what we called a whiz wheel, an in-flight computer mechanical. It was basically it was a circular slide rule.
Right.
And just worked his butt off.
Right.
The co-pilot was working pretty hard because he was also the flight engineer of a very complicated airplane.
Right.
Which is why we really wanted to have a lot of experience as a co-pilot before you upgrade to crew commander, so that you have a full understanding of all those systems and how that all works.
And who's the fifth guy?
Then you got a ECM operator, who we always called the EDUB or EW, electronic warfare officer. Okay? He's trained as a navigator, and after navigator school, he goes to electronic warfare school. And those guys tended to be the highest IQ. After a while, if you're also being close, you could almost always pick out the ECM operator on another crew. Must be that guy.
Right.
You can tell by the way they talk.
Because what is he? So what's his job?
Well, what made it really different when I first got into B-52s, most electronic warfare was what they call noise jamming. It wasn't real sophisticated. And so he would listen. He had a bunch of sensors to listen to a bunch of frequencies. And he had to be able to identify from sound. Part of his check ride was he'd go into like a hearing booth, and they would play beeps and squeaks for him. And he had to be able to say, well, that's an SA2 guideline operating on upper side lobe, and I need to jam that with my ALQ 123, and it was a very, very cerebral job.
Yeah,
and that's why you could kind of pick these guys because they tend to have high IQs, really smart guys.
So his job basically was to interfere with attacks on your aircraft.
Him and the gunner were the defenders of the airplane.
The defenders of the airplane.
Yeah, we called them the defense team. The navigators were the offense team, and then there was a pilot team.
Right.
And sitting next to him on the G&H models was the gunner on the left side of the airplane, but facing aft. And his gun was entirely radar aimed. He had no visual backup at all. Up through the F model, he sat way back in the tail and had some visual capability.
This is the little turret looking thing that hung down from the back of the aircraft.
Yep. And he sat.
And this is a 50 caliber weapon, or
there are 450 calibers up through the G model. Yeah. The H model had a 20 millimeter rotary cannon instead. It was a devastating weapon. The same weapon the fighter's going to carry. Right?
All right.
But if he closes at 6 o'clock, you got a 50% range advantage on him because he's flying into your burst, and we're flying away from his.
Right.
So when we did practice intercepts for guns, we had to ask the fighters to make tail attacks because they understood it was essentially suicidal to approach a B-52 within gun range. Because the gunner's got all the advantage. His gun's gyro stabilized. Those 20 millimeters were almost fully automated system, way ahead of their time for being developed in the 50s. Because they were the same tail gun that the B-58 had. Right. And it was designed to be operated
from the forward.
Facing forward by a guy who's also got to do ECM stuff.
Right.
So his workload on the gun had to be low. So it had a lot of automatic features and everything. Back in the days when there's vacuum tubes and relays again, it was way ahead of its time. It's so simple to use that when I was a young co-pilot, we had to go out and do intercepts. I'm sure it was with F-4s. The day before the flight, the gunner sat me down and gave me a instruction on how to use this thing. Then we got up there, we swapped seats, and I got in the gunner's seat, and I got tracking gun kills on the first couple guys that closed at 6 o'clock. Never done it before. It's amazingly simple. Just a lethal weapon. So when they took it off, in most of our opinions, the B-52 really took a hit. If you don't have lethal defense.
Why would they have taken that off?
General McPeak was the chief of staff of the Air Force. And one of our rewards for winning Desert Storm was he fired all the gunners as soon as we got back.
Well, good.
That was one of his many crimes against humanity.
Well, good. Too effective.
Yep.
At killing people and breaking things.
Yep.
So we've got
we
need a handicap.
I don't want to go on and on about that guy, but I don't know of an officer who served under him that would have spit on him if he was on fire. No respect for the guy at all.
Not to dwell on this, but what was his fucking reasoning?
His reasoning was it's antiquated equipment, and we don't need this anymore, and the fighters can protect the bombers.
But that's stupid. Why would you not want a redundant system?
Yeah. No. They talked about doing smart things like putting Stinger missiles on her. Mm-hmm. You know, the Stinger was designed as an infantry-launched anti-aircraft missile. Mm-hmm. And so it was designed to do what we call a face shot. It was designed to shoot at the fighters coming right at you.
Right.
Would have been perfect to put, and with the weight of a B-52, you could put 50, 60 of those things back there.
Right.
You know, but no, they just fired the gunners instead.
Just took away the capability.
Took away they were the very last defensive aerial gunners in the United States history were fired after Desert Storm. So, by the way, I'll get this on here. The thing I'm probably most proud of for 20 years of active duty was I was made an honorary gunner in 1987.
Really?
And that's not something they did for retiring colonels and crap like that. It took a unanimous vote of every gunner in the wing. And any one of them could veto you anonymously. So I got that certificate in my cube now at work. And I got my gunner's coin. You know, in the Air Force now there's this big thing about challenge coins. Well, the gunners invented that.
Yeah.
Their mascot, their unofficial mascot was a bulldog. And so they got Mack trucks to produce a bunch of coins that had the Mack bulldog on one side, and on the other side it says, "You make the difference." And that was the gunner's coin. And when I became an honorary gunner, I got one of those. And there's this whole game you play with. You got to have it on you at all times and stuff. And so I learned to, when I took a shower on alert, I would put that thing in my mouth. Because if they ask you to see your gunner's coin and you don't have it, you owe them. Okay, you owe them a beer or a Coke or something.
Or something.
Yeah. And so it was a whole game to play. The gunners played amongst themselves, and if you're an honorary gunner, you're a gunner.
Right.
And they'd love to get an officer this way. I was standing outside a building at Shepherd 20 years ago, back when I was a smoker. And I stand outside smoking, and this car comes up, stops and backs up, and out jumps a guy I hadn't seen in 10 years, a gunner, and he's at Shepherd to do some other school, and he runs up and he says, "Got your coin?"
That's great.
And I did.
As a matter of fact, yeah.
I've had to stop carrying it because I'm scared to death I'm going to lose it, and there's no
Right.
replacement.
No.
So I'll get busted now because I keep it in my desk drawer at work because
Right.
I don't want to end up, falling out of a torn pocket or something like that.
Paying for a Coke with it by mistake.
Well, I just want to
or
lose the
something like
coin.
that. Yeah. Right.
I accidentally put it in a coffee fund one time, and this building I was in was all officers, so there's no gunners there, and everybody knew I was an honorary gunner. So as soon as that coin showed up, they knew exactly where it came from.
Right.
So they brought it over to the squadron gunner, and he called me up and he says, "I'll give you your coin back. Cost a keg of beer." Sold. Next gunner's
All
party,
right.
I'm buying the beer. you gotta take your
Right.
medicine with it, But that's just a cool the gunners had all kinds of cool traditions and
Yeah.
stuff. And it was just sad to see them go. Culturally, I thought it really hurt the bomber community to not.
Well, yeah, you got a general making political decisions. Isn't that good?
Yeah.
Isn't that good? So when you bomb a target, and I understand that you had never dropped a nuclear weapon because nobody has since Nagasaki.
Right.
And
Well, not in anger.
well, not it. Yeah, we've test
They
dropped.
test dropped some.
We've test dropped. Well, more than people think.
Yeah.
Quite a few more than people think. There have been 265 or 70 sub-aerial
I don't know the number.
nuclear. It's in the high 200s. Nuclear tests in the United States. If you out in Nevada and out in the Pacific, we blew up a hell of a bunch of bombs
Oh yeah.
because we had to figure out how they worked.
Exactly.
And those of you that have not seen the atomic bomb movie,
1,054 tests from the United States. That's the official.
But that's not just, that's all includes all tests.
that's underground. That's underground.
Yeah.
But yeah, we did a sub-atmospheric test. We did
216.
216.
Yeah.
Okay, yeah, that's good. So there've been 216 atmospheric tests of nuclear weapons. There've been a bunch of underground tests that aren't really the same thing. But those of you that have not seen the atomic bomb movie need to watch the atomic bomb movie. It's narrated by Shatner, and it's footage from nuclear weapons tests conducted by the United States. And one of the most unforgettable things you will ever see is Shot Baker. This was at Bikini Atoll in 1946.
Is that right? Yeah, it was
I
right
believe
after the war.
46 is right after the war.
Yeah.
1946. They were still learning about the technology, and they did a surface explosion. That what they did was they hauled a bunch of ships they were going to scuttle anyway out here to this.
And some captured Japanese ships and stuff. Yeah.
That, and they just had a bunch of floating targets basically out there, and they anchored them, and they wanted to see what a nuclear weapon would do to these damn things. So they took 50 or 60 ships out there, and they're anchored in various positions. And Shot Able was the first one, and that one was like 200 feet in the air or something like that.
Yeah, it's an air booster.
It was an air burst. And it fucked a bunch of stuff up real bad. And then Shot Baker was the second thing. And this was, by today's standards, not a terribly high-yield weapon. And I don't remember what it was.
Neither do I.
I don't remember what it was. But it wasn't a 9-megaton device like we made thousands of. It was a low yield, normal atomic bomb, not a fusion weapon or anything, but it was because they didn't have those at the time. But it was might have been boosted. I don't know, but this is the damnedest video you will ever see. You are watching 150-foot long battleship hulls. All right, so let me back up. This bomb was set at 300 feet of depth of water. I think that's right. Yeah. I believe it's 300 feet deep. So they sink the bomb, and they hang it off a raft, and it's 300 feet of water. And then they detonate this thing, and you're at a position of, 10 miles away where they're taking this video, and the goddamn thing is lifting these 150-foot long hulls straight up in the air, standing them on their end.
Oh, yeah, some of those ships are a lot longer than 150 feet, too.
And it's just the volume of water that goes up in the sky. It is the damnedest thing you have ever seen. If you haven't watched the Atomic Bomb movie and you're still listening to this thing we're talking about here, you're crazy. You need to go right now and order that. The Atomic Bomb movie. And it's a fascinating thing to watch. It really is. But so nuclear weapons are a theoretical thing, basically.
What do you mean by that?
By that, I mean their application is theoretical. Since we haven't done it but twice.
Right. Okay.
We haven't done it but twice. We don't know precisely what a 9 megaton weapon would do if it was dropped in the middle of Houston. Or better, dropped in the middle of Los Angeles. I can live with that. But so we don't actually know what would happen. We're pretty sure, from all the testing, we're pretty sure what the effects would be. But these things have a completely different use in terms of tactical use than do conventional weapons.
Sure.
Right?
Yeah, but with the so-called tactical nuke, you're still looking for blast effect. The weaponeers consider the radiation and fallout.
Let's talk about their tactical and strategic are two different things.
Right.
Strategy and tactics.
Right. So a tactical nuke would be a battlefield nuke is another name for it, where your target is enemy armor and infantry.
Right. This is the target. We need to destroy this thing right here. So those strategic applications are big things.
Big bombs. Take out hardened targets or large targets.
Or geography.
Right. Yeah. And so typically in the big nuclear war plan that was called the PSYOP, that was so much a part of my life for so many years. PSYOP stands for Single Integrated Operating Plan. And because all of our nuclear weapons they were all in one big plan for the big retaliation. Each year, the plan got more and more complex to give the president more and more choices.
And we're talking about the response to a Soviet attack.
Exactly. That's the only way we would have launched.
Right.
That's where the deterrence comes from. You can start it, but you can't win it. Is what we're saying to them.
Right.
Okay. Those weapons tended to be large weapons delivered by bombers. All those missiles, submarine and intercontinental ballistic missiles, tended to be targeted on the defenses against bombers. Now, that's a very broad brush statement. There's lots of exceptions.
Mm-hmm. Right.
But the missiles couldn't carry the payload that bombers could carry. So essentially, in a broad brush statement, missiles knock down the defenses because the bombers aren't going to get there for hours after you've launched the missiles. And then we'll go in and carry the heavyweight weapons and take out the target.
That's the strategy.
That's the again, very broad brush overview of that big PSYOP plan.
Right.
Okay. So as we got more and more warheads, there was more and more things we could target.
Mm-hmm.
When the air-launched cruise missile came along during the Carter administration, it became clear that the targeters didn't even know what to do with all the warheads they had. I don't know that we ever disclosed how many warheads the United States had. I don't know what it was. But it was a lot.
Thousands,
yes. And I did see at the time a top secret thing that showed a map of the Soviet Union and the Warsaw Pact, and it had these clear overlays for every hour after we launched this big attack. And I got convinced that if we ever do this, there's not going to be anybody to shoot at me by the time I get there. We're going to bury
We
those
had
people with
that
nuclear
much
weapons.
nuclear ordnance.
It was amazing. So the hard part was going to be we're not going to survive because we had no shielding from radiation. We didn't even have any armor plate on the airplane. And so we're going to fly through all that fallout from thousands of warheads. You know, you're not going to live more than a couple weeks.
But theoretically, this is still not a suicide mission.
U.S. doesn't do kamikaze missions. They were all planned, and they were all planned. I had faith that there was fuel to get done what we wanted to get done. However, okay, if you take off and shortly after takeoff you have malfunctions, there was a decision tree to go to in the kit that we had, and you would go through this. You know, if this is your problem, then do this, and yada yada. And what it got down to is, in the extreme, if this is really the thing, and we know this war is on, if you can reach your first target and get a safe, what we call safe escape distance beyond, then you're going to go. So because this is it,
Right.
you know, and we need that one more weapon. So we don't plan suicide missions, but it could end up almost being like that.
Right.
And I really think most of us, of course, all, like you said, hypothetical, but I really think most of us would do this because the fact is, the reason we're doing this is because the Soviets have just killed my wife and kids and everything I care about.
Right.
So
This
I
is
got to pay
not
them
in
bastards
response
back.
to just losing a poker game.
Right. Yeah.
Right. This is everybody's motivated.
Yep. I really think we would have been. Yeah. We'll never know because thank God it never happened.
Right.
But you know, we couldn't know that on the time. You know, I spent 7 days at a time out there with you know, I lived feet away from that nuclear armed bomber, and the whole point was get in the air as fast as you could.
Right.
To go pay him back. So it was a very grim view of things. You know,
Right.
there was the tankers. We would on a nuclear mission, we'd refuel almost as soon as we got to altitude, and the tankers would top us off. If we needed to, there was a code we could pass to them that said, give us all your fuel. And in their standpipes, they had enough fuel to turn out of our way before they flamed out. So that's how grim the whole thing was.
Give us all of your fuel.
Yep.
Wow.
And you can't bail out of a KC-135.
There's no ejection system for that.
No. And you can't
And
manually,
you're over the Arctic Ocean anyway, so it doesn't.
and you can't even manually bail out of it. They stopped carrying parachutes some time ago because it was just kind of a
There's
joke.
just no way to use them.
Yeah.
Right.
So if this happened, but again, remember, if this happens, it's because the world's going to end as we know it.
Right.
So
All right. So how do you drop a nuclear bomb? All right. So you got a payload of nuclear bombs. How many are in the airplane?
it all depends. I've pulled alert with as few as 2
Right.
and as many as 20.
So would you drop 2 bombs in a different way than you would drop 20 bombs? Obviously, there'd be a different operation to
Yeah,
to
hypothetically,
do that,
there's 3 kinds of ways to deliver a nuke. You can do an airburst, where it detonates at an altitude. Okay, this is how you get the widest spread destruction. If you detonate it at exactly the one radius of the fireball, you can get the most destruction on the ground.
So they know the maximum fireball generated by the weapon.
That's why all those tests.
Right.
You can do a ground burst, where it detonates like conventional munitions on collision with the ground.
Right.
Or
And
you
then
can
you've
do-
got a rather abbreviated version of the
You get less widespread
less
destruction.
widespread destruction.
But
because
it might be more useful to dig out an underground target.
Right.
And then the third way is you can do what we call a lay-down release. And in this, you release the bomb, and it has parachutes that carry it to the ground while you're escaping.
So it slows it down to give you time to get the hell out of there.
Right. And so it's going to lay on the ground for whatever time is programmed into it.
Couple of minutes.
Yeah, a few minutes while we try to run away, get safe escape distance.
Right.
And certainly not enough time for anybody on the ground to do anything about it.
Right.
You know, it's going to go.
Right.
And all of the sorties that I pulled alert on, all of the releases of bombs were lay-down releases because we're going to be at extreme low altitude to escape the defenses.
So you're at 1,000 feet.
Or less. 1,000 would be pretty high on a combat mission.
So you drop the bomb out of the bomb bay. It's under a parachute immediately as it leaves the.
Yep.
So it slows down, and it's obviously sturdy enough to whack into the ground
All designed to do
without
that, yeah.
breaking.
Right.
Right.
All designed for that.
And again, if you know how nuclear weapons work, the impact does not trigger the nuclear weapon. So you're getting the hell out of there, climbing apparently.
Yeah, usually staying low.
Really? Stay low.
Climbing will expose you to more of it. And it'll expose you to
ground
more
defenses.
defenses.
Right, yeah, I suppose.
But it'll
yeah.
expose you more of the blast, too.
Oh, really?
Yeah, it's better to be down. Kind of think
I
of it
guess
as
it
it
would,
going
yeah.
over your head,
Right,
kind of, if you want to
sure.
think of it that way. Some of the terrain will shield you from
Right.
some of the
I
direction.
see that. I see that. And if you climb up, now you're exposed to the
The shock wave.
the shock wave, the spherical shock wave, more than if you're down being protected by terrain, trees,
So we're escaping just with
topography,
speed,
that sort of- right.
basically. And so we knew in advance what the bomb was programmed to know what our safe escape time was. Right? And at that time, then it would finally go off.
Right.
And you're not that far away from it. I mean, that's kind of a subjective statement.
Right.
But I would think the distance is probably smaller than most people would guess. It's just going to be a few miles. It's not going
5
to
or
be
6
30
miles.
miles or something.
Right.
Because by being down low and everything, the weapon isn't as destructive as a lot of people think, honestly. I mean, it's certainly more destructive than conventional weapons. But people look at pictures of Hiroshima, okay, and they think that the bomb did all that damage. The fact is, the fires that the bomb started
Right.
did all that damage.
Did all the damage.
The city is made of wood and paper, burned like a
Right.
cigarette, The initial blast, in fact, some of the survivors were underground in I think it was a library, and only a few thousand feet from the ground zero. But because they were protected, they survived.
Right.
And other people that were 3 times the distance away didn't because they got a full blast of gamma radiation and they're done.
Right.
Or the blast wave killed them. So most of the destruction you see when you look at these aerial shots of Hiroshima, most of that was fires started by not the
Right.
nuke.
Our firebombing campaign in Tokyo killed far, far more people
And one night.
in one night than both of the nuclear weapons together
Yeah.
did. That was Curtis LeMay's
He's
coup de
man.
grace. My God, that was
Yeah, they actually
was-
they calculated the mixture of high explosives and incendiaries that would create a self-sustaining tornado of fire, and it would feed on the buildings as it moved through the
as
town.
it moved through Tokyo. 650,000 people,
I don't remember.
something to that effect. Some insane number of people died in the firebombing of Tokyo, far more than
Yeah.
we killed with the two nuclear, the more famous.
And Tokyo
nuclear
wasn't the
weapons.
only place to undergo firebombing.
Right.
No, there was a lot of civilian casualties for that.
Yeah, it was an ugly situation. There's
And
no,
to the
absolutely not.
strategic planners,
Well, that's
they
what-
were targets.
That's what
right?
strategy. That's what strategy is.
Yeah.
Strategy is a big thing you do to make the other side stop fighting with you. Right.
Right.
So in that way, in that respect, you can do strategic bombing with conventional weapons, and that's what carpet bombing is. Right.
Sure. Yeah. Well, carpet bombing, in my experience, usually the target is infantry.
Right.
Okay? Like in Vietnam. B-52s dropped so many tons of bombs onto the jungle. And the critics will talk about them bombing this empty jungle. And that's not an empty jungle, okay?
No.
There's infiltrators. There's a Ho Chi Minh Trail down there, right? Valid targets. And just because you can't see it because of the canopy
Right.
doesn't mean you're not killing people down there.
Right.
At Khe Sanh, the whole point of Khe Sanh, set up an artillery base that gives the North Vietnamese a choice. If you leave that artillery base there, it's going to cut your supply trail. So you must put a set-piece battle, in fact, to overrun that place. That was the strategy. When we knew they had their people together, the B-52s came in and killed them by the thousands. That was the purpose of it.
It was the decoy for
Right. It was to get them into a fixed location
into a killable position.
that they had to do. They had no choice. They had to do that. We even killed a North Vietnamese general during one of those attacks. So that was massively destructive and a massively successful effort
Right.
that the historians have written up as a mistake.
Yeah. Politics
Right.
dictates the history.
Right.
Right.
But yeah, you'll see these things critiquing Vietnam all the time and showing they're just blind bombing in the jungle out there. None of it was blind. All of it had targets. You know?
Yeah, we don't drop bombs not knowing where they're going.
Yeah.
They're too fucking expensive.
Yeah. The closest I ever saw to that was during Desert Storm. Some of the bomber B-52 units got scud hunting missions, especially after they got lucky and killed 14 Air Force people with one of their scud missiles.
Right.
So this mission was they would load up with cluster bomb units, and they would orbit over Kuwait and the Saudi Peninsula. And if the satellite detected a scud launch, they would run in and just spread those CBUs over a lat-long, latitude, longitude, hoping they could get the scud launcher before it moved. And I don't know if we ever got
and
one.
A scud launcher is a device that has these little missiles.
Yeah, it's a ground launch. It looks like an 18-wheeler with a big missile on the back.
Right.
You know?
And so if you go over there where you detected its presence,
maybe it hasn't moved yet.
and maybe it hadn't moved yet, maybe it's moved a little bit, but if you do a radius from that original detection point, then you are likely to disrupt the.
Yeah, it was.
So that's a strategic.
I'm sure
thing,
that
right?
the intent here was to tell you it's not free. If you're going to launch these missiles, it's not free.
Right.
We're not going to just let you do this.
Right.
And I think that mostly came after they got lucky and they hit a barracks on a base in Kuwait.
Well, I said that was strategic. That'd actually be a tactical attack.
That'd be more tactical.
Yeah. Since it's a target that needs to be taken out. Right.
Right.
Right. But if you're going to deny the use of a piece of property to the enemy and just disrupt every piece of existing infrastructure in that area, and that would be a strategic type thing that you would do with a whole bunch of 500-pound bombs dropped one right after another on top of this target.
Yeah, like during World War II, the U.S. went on a ball bearing campaign with their B-17s. Because it doesn't take a rocket scientist to figure out that a modern army moves on ball bearings. If I can deny them ball bearings, I'm going to affect airplanes and ships and tanks and everything.
Everything that rotates.
Right. So they went on for a couple months. Almost all the targets were ball bearing factories. Okay? In the end, we find out after
That
the
was
war.
Dresden, right?
Dresden, I think that was in no, Dresden was a fireboming. Schweinfurt,
Leipzig.
I think, was
Leipzig was.
yeah.
But like there was a ball bearing factory in Leipzig.
But we found out after the war, after the strategic bombing survey, by the time we started attacking these ball bearing points, the Germans had already dispersed the industry pretty well, and we didn't hurt them all that bad with it. You know, the strategic bombing survey sometimes is touted as showing the failure of strategic bombing by opponents. In fact, it was a success. It just wasn't a success the way we thought it was going to be.
Right.
We thought we were going to deny them their factories and their ball bearings and their oil, which we did some of.
Right.
But its major effect was it made the Germans expend huge amounts of resources to defend against
Moving the
it.
shit around.
And every bullet they fired at a B-17 was a bullet they couldn't fire at my dad in his armored half-track, you know? Mm-hmm. And that part was the success. They had to spend they couldn't just let us do it. So they had to expend massive amounts of resources defending against it. Mm-hmm. And that was the major positive effect of that strategic bombing. So it was definitely worth doing. You know, it just wasn't, we were kind of surprised at where the effect was. We thought it was going to be denying them resources, but actually it was making them expend resources.
Right.
You know? So it worked. It was worth doing. In Japan, it worked more the way we thought it would. You firebomb the whole city, the factory's not going to be there anymore.
So when you're going to carpet bomb a target, how many ways are there to do that? It seems like you could line the aircraft up.
Well, if you're going to...
Or you could nose to tail, or wingtip to wingtip.
Exactly.
And get two completely different effects out of the application of those.
Right. So if you want to put a lot of bombs in a wide area, then you fly usually a 3-ship formation in a V shape, okay, and they all release at the same time, and you put a lot of bombs in a large square mileage, okay.
Right.
But if you want to just pound,
what would that be for?
Again, infantry that you know is dispersed,
Right.
you know, The jungles in Vietnam where you can't pinpoint each guy, but you know they're down there.
In the area they're in.
Right.
So you.
And sometimes that's called area bombing, too. The British called it area bombing in World War II. But there's another way. If you want to continuously hit the same target or contiguous targets that are all in a line, okay, then you can line the guys up nose to tail. And normally we flew a mile in trail and stacked up 500 feet. So each guy was 500 feet higher than the guy in front of him. This keeps you from flying through the guy's bomb train in front of you. And then you don't release simultaneously. You release as each guy gets to that point. So now you're going to have 3 bombers all dumping on the same target. So you're not going to have as many square miles, but you're going to put bunches of destruction into a small area.
Can you imagine what the hell that is like on the ground?
This is why when
the whole thing just turns to just disintegrated vapor all around.
We knew the ground war was about to start because the targets all changed to carpet bombing and that kind of bombing of the Republican Guard on the Kuwaiti border. And that's when we knew, okay, 2-3 days of this, the ground war is going to start. And that's why when it started, there's film of Iraqis trying to surrender to drones because the survivors, they're not hardly soldiers anymore at all. They're just, if you live through this, you're going to be bleeding out of your eyes and ears. Your internal organs will be turned to mashed potatoes, you're not a fightable guy anymore. So it's devastating way to do business.
Yeah.
And you can't stand up to it. And
I don't guess anything could withstand such a treatment.
No, I was sitting in England because I didn't fly any combat. I planned missions and brief missions instead because I didn't have my own crew. You had to have your own crew to fly missions. And by then I was a staff instructor pilot anyway. I remember sitting next to a nurse at the officers club there at Fairford, and we're watching CNN International, and the so-called expert says, well, this bombing like this isn't doing any good. The Iraqis have had 6 months to dig in there, and they're not really, all they're doing is rearranging the sand on the desert floor. What a moron.
What God,
This was the same guy a few weeks earlier. I was sitting with this same nurse, and he says when the ground war starts, it's going to be a massacre. The American tanks are going to break down in all the dust and sand, and the crack Iraqi army, which just fought an 8-year war, is going to be ready for them.
They're a sharpened sword.
Yeah,
I remember all that shit.
And so the same nurse, she's there to man a hospital that we expected a lot of casualties. And so, of course, her concern is, gee, do you think this is true? Am I going to be having to deal with a lot of casualties? And I said, do you know where the U.S. Army does their training? In the Mojave Desert. They've been doing it there since World War II. They're absolutely a desert force. Right. That was the war the U.S. Army trained and equipped for since Pearl Harbor. A war of maneuver without any chance of civilian casualties. There wasn't an army in the world that's going to stand up to the U.S. Army in that circumstance. Nobody. Oh, God. So what a moron this
guy. I remember all of that propaganda that was circulated before.
I mean, even I was shocked by just how light our casualties were. We were all expected more than that.
Just, a couple of thousand, something like that?
Oh, yeah, I'd be surprised.
I mean, the whole damn thing, right?
Yeah. When we deployed, they told us to expect 50% casualties in our B-52 unit.
What?
So they told us to expect.
Has any B-52 unit ever experienced 50% casualties?
No. But, of course, on paper, the air defenses around Baghdad and those places were pretty dense, But what wasn't factored in by whoever thought of this, no doubt, was the effectiveness of wild weasel fighters. The guys whose job it is to go down and lure them into firing a missile so that they could shoot a missile back down its throat. Incredibly
Reveal
effective.
Their position.
Yeah, incredibly effective thing at suppressing the surface-to-air missiles. So just like the North Vietnamese, the Iraqis learned the first night, if you bring up your radar, you're going to die because that thing rides the radar beam back.
We can see your radar.
Yeah. Those missiles were designed to ride that radar beam back to the antenna. And they're hypervelocity anti-radiation missiles, HARMs, and they're incredibly effective. So that's why we were able to go high altitude in Desert Storm, is because those guys suppressed all that. On paper, it was dense defenses, but in reality,
we turned them useless.
Yeah, you can't afford to turn on your radar.
Right.
So what my guys would describe to me typically is They'd be over Iraqi territory, and they would see a SAM, surface air missile radar, come up over at 2 o'clock, and it would sweep them twice and go off. And then 5 minutes later, they'd see another one come up over at 9 o'clock, and it would sweep them twice and go off. And then, obviously, what they were doing is they were calculating where we were going to be in the future, and they would fire off surface-to-air missiles unguided by radar, which means they're just expensive anti-aircraft artillery rounds.
Right.
And they never got anywhere near any of our guys. But that was their only answer to this, because if they kept that radar on, they were going to die. Because we sent guys, in these F4Gs, which is the Weasel variation,
Right.
down on the deck trolling for you. Yep.
Right.
Those guys had a big pair, right? Because they're down there, they're trying to get you to shoot at them,
Wow.
So, but
Yeah, I read about the wild weasel thing. That was what an amazing and it's kind of interesting to me that they use the F4s for that.
I think it was.
I would have thought there was a better aircraft for that.
I
for that
think it was
particular-
its ability to accelerate. The very first wild weasels were F-105s, two-seat F-105s,
Right.
and nothing accelerated at low altitude faster than an F-105 because they could run the afterburner at very little thrust. So when they needed speed, they could slam that and it was already lit. So it would be,
Right.
I guess it felt like just getting kicked in the ass.
Oh yeah.
And so that's why
2 or 3 Gs.
that's why the F-105 was chosen as the first weasels. Right? And I don't really know why they've shifted to the F-4G. I honestly don't know why. Maybe it could carry more ordnance or.
Is that mission being performed right now with?
They don't have
airplane?
specialized squadrons doing it anymore. It's an additional duty for certain air-to-ground fighter units.
Right.
So it's one of several things they may do. So in bombers, we kind of didn't want to see the dedicated ones go away. Those are fighter pilots we'd buy drinks for. They made our life easier.
They cleaned things up for you.
Taking after Francis Gary Powers got shot down, we were all forced to go down low. Everybody.
Right.
And because low is your only chance against the defenses. If you go high, the SAM's going to get you eventually. The problem with going low is now everybody with an AK-47 gets to pop one off at you.
If they put a 7.62 round in your engine intake,
Yep. Yeah.
some guy on the ground can.
Yeah, a huge percentage of the losses in Vietnam were ground fire. We lost over 100 planes in air-to-air, if I remember right, but that was a fraction of the total losses. It was ground fire that brings them down. So if you're a country and you're buying a surface-to-air missile, what you're trying to do is force your opponent down to where the guns can kill him. You don't really care if the missiles get
Or
him.
the cheap guns
Yeah,
can kill
you
him.
don't really care if the missiles gets him or not.
Right.
Because it's going to force him down to where. Well, wild weasels took that away.
Right.
So we could go back up high again where we were immune. The only gun that the Iraqis had during Desert Storm that could theoretically reach us was this Russian 100-millimeter anti-aircraft gun. And all you had to do was offset a half mile to the side where someone no longer could reach you. So they banged away. They shot them without guiding it. And so the guys would see flag bursts on there, but it was never anywhere near them. So there wasn't. I don't think there was a B-52. The most threatened B-52 was a guy that took one of those HARM missiles in the tail.
Right.
That's how good that HARM missile is. He hit an airplane going 300 miles an hour. Wow. They didn't disclose all that till after the war. But
What is the biggest danger to a B-52
biggest danger? I mean, from an enemy?
from the enemy? What is the most effective thing he can do to you?
Well, ground fire, if you're forced down low, is pretty lethal, and it's hard to counteract it. It's hard for your ECM operator to jam it because you're not going to be exposed very long. SAMs are bad if you don't take them out, if you don't eliminate them. I got shot down at Red Flag a couple of times by F5s. And that was a T-38 that they put guns on. They sold them some foreign sales. The Vietnamese bought some. Very good fighter, but it was a very basic World War II day fighter that went fast. Had no radar on it.
Right.
And that's why they got us at Red Flag, because we couldn't see
Yeager
him.
said that was his favorite airplane to fly.
Doesn't surprise me.
Yeah.
No. I think there's thousands of pilots out there that'll tell you the T-38 was their favorite airplane.
Yeah.
It's just a pilot's airplane. I had a few hundred hours in it after pilot training, because in the 70s and 80s, co-pilots in SAC were dual qualified in their primary airplane and then a T-37 or T-38. And then Grand Forks we had T-38s. So we just logged time in those things, you know. And you can't imagine two more different airplanes in every possible way than a B-52 and a T-38. So it was a good experience, actually.
B-52, I think you told me one time, it's like flying a building.
Oh, yeah. One of the jokes, and I can't remember it exactly, but it goes something like this. The 8 engines have more power than 25 locomotives. There's 15 miles of wiring in the airplane. Right?
Yeah.
And it flies like 12 locomotives being pulled by 15 miles of cable. Not from a stick and rudder point, it's not a pilot's airplane. Right. But the pilots love it because it has a tendency to bring you home. You know? Right. And it can do things other airplanes can't do.
Well, I guess that's why they're still using the goddamn thing after 60 years.
They've never really, I'm editorializing, the Air Force has never really asked for replacement. By that I mean every spec they put out for a new bomber does not carry more stuff further. And those are the two things you care about. The B-1 on paper can carry more, but our standard joke was, yes, it can carry more, and if the target's near the departure end of the runway, it can attack it. But it doesn't have the range. It burns so much fuel. It just doesn't have the range. Right. It does have speed. In Afghanistan, it's been proven pretty useful because there was always a B-52 and or B-1 orbiting with these joint direct attack munitions, a guided bomb. And if it was a B-52 and you're an Army lieutenant on the ground and you say, I got a target for you, if he was on the other side of Afghanistan, it was a much longer wait for him to get there than for a B-1. The B-1 liked those 4 big afterburners, and he's smoking. There's nothing faster right down on the deck than a B-1. It's in a straight line, it just goes. Mm-hmm. So I've talked to more than one of my fighter pilot friends who said it's almost impossible to intercept the things low altitude. They just run away from you. You just can't get a good intercept geometry on them because they're moving so fast. And that was what it was designed for, was speed. So in Afghanistan, that's been pretty handy, I understand.
Right. So if you've got a combination of B-1s and B-52s, you've got the whole mission pretty thoroughly covered.
Yep.
And why would you want to spend hundreds of billions of dollars developing a new airplane that does what the B-52 has been doing for 60 years?
Yeah.
I guess it just doesn't make any sense, does it?
Well, they've put out the spec for a new replacement, the B-21. I don't know if they've released all the details on range and payload, but it's clear from looking at the artist conception that stealth is their major thought.
Why don't they just remanufacture some new airframes for this silly-ass thing? I mean, they know what to do already, and they could go in and tweak while they're remanning the B-52, come up with a new engine combination. Now, why would you want to rethink the wheel?
I don't know. They don't ask me these things.
Because it's not about the product. It's about the contract. Right?
Yeah. Yeah. You know, the F-16 is like that. We acquired more than the Air Force said they wanted. And that was a political decision to keep people working.
Sure.
Now, not that that's a bad airplane. It's been an incredibly successful airplane after its initial teething problems, you know. But the Air Force said, we want X, and Congress said, you're going to get X plus.
Right.
So the acquisition process is highly political because it's politicians that control the purse strings.
Politicians making decisions about money.
Yep.
And there's always a different agenda.
Yep.
Than what the end user wants.
Right. So I liked the historian in me, likes the old system that created the B-17. And that was the Army Air Corps saying, we need a plane that carries this many pounds this far. That's it. We're not going to tell you how many engines. We're not going to tell you.
You solve those
problems. If it carries
problems.
this shit this far, we'll buy it from you.
This is what we need.
Yep.
Need it to do. You figure out how to make it do that.
And so Boeing builds a prototype at their own expense. The taxpayers don't buy that.
Right.
Because there's a potential for billions of dollars here if you get the contract. Mm-hmm. But the taxpayers don't pay for all that development. That's your problem.
I mean, that's part of the cost of doing business.
And that's the process that got us B-17s. It got us the P-51. The P-51 started as a private project by North American Aircraft Company. They built a plane hoping they could sell it.
They just had an idea that there was, if we build this, maybe there's a market for it.
Exactly.
Right. Which kind of makes a lot of sense, doesn't it? That's what the developers should be doing.
Right. But nowadays, they complain it's too expensive, so the taxpayers got to help us do the prototypes, and if I was the king, I would go, suck it up, because there's a potential for you to make billions of dollars.
Don't do it wrong.
Yeah, and then you'll get their
because
contract.
you'll be paid if you do it right.
Yeah, and this whole thing, one of my favorite stories about the true story about the P-26 pea shooter built by Boeing, interwar airplane, low wing monoplane with fixed gear. Okay? Boeing built it where it didn't have any external bracing by cables. Like you look at World War I airplanes, they always got. It didn't need any external bracing. The Army Air Corps generals didn't like it without bracing. They didn't trust it.
Because they didn't like the way it looked.
So Boeing went back and put completely unneeded cables all over it.
Vestigial cables.
Yep, and sold it to Army Air Corps. Then they bought it. So the process wasn't perfect even then, but I think it was better. This is how you get a Sherman tank that won the war. This is how you get Missouri-class battleships that won the war. All the hardware, not just airplanes.
Right.
You get this when private enterprise says, I can do better than my competitor, and if I do, I'll make billions.
Right.
That's a system that works.
Right. Well, back to the B-52, what an amazing device that thing's turned out to be.
Incredible.
I mean, there's not anything in the world like it.
There's guys flying it now that say my grandfather flew it.
Maybe the same airframe.
Possibly the same airframe. There's not 100 airframes left, so very possibly the same airframe.
Oh, God.
And I think still out there is one of those that had the vertical stab knocked off, so they had no rudder or vertical stabilizer.
And landed it.
Yeah, they flew it hundreds of miles. And they landed it back at Edwards, and they called up Boeing and said, well, what do we do with it? And they said, we'll send some guys down and get it. And they took off and flew that thing without.
It flew the thing without the vertical stabilizer.
Flew the thing back to Seattle, fixed it, and I've flown that airframe. It was at Grand Forks when I got there. It was an H model. I can't remember the tail number anymore, but you knew it because when you reviewed the maintenance forms, traditionally the first form in there for inspections that were overdue or sometimes never going to be done.
Right.
There was a write-up by Boeing test pilots that they should inspect the airframe because they had 60 seconds of inverted flight after they put the tail back on that thing. Yeah.
Are you serious?
That's what the write-up said. And that was they did that because they put that tail back on there and they wanted to test fly it, And they wrote up, I don't know if they're telling the truth, they wrote up 60 seconds of inverted time. And that was famously the first overdue inspection in those forms for that tail number. Because since it isn't designed for inverted flight, probably it should be inspected. But we don't know what inspections to run because it wasn't designed for inverted flight.
For doing it. We don't know what to look for.
So,
well, let's check it anyway.
Yeah. Nobody knows how much of that was just bragging by these Boeing test pilots. So that's what the write-up was.
So B-52, what an amazing invention by Boeing. Probably the smartest thing they ever did.
In my opinion, yeah.
Yeah, obviously. So, well, that's our show. I hope this has been as interesting for you guys as it has been for Scott and I. Every time we get together, we talk about, I just pick his brain for an hour or two every time he comes to the gym, and I thought it's so damned interesting, I'd just let you in on some of it. So, next Friday, we'll get somebody else on here. It probably won't be this good, but thanks, Scott. Thanks for being with us.
Hey, thanks for having me.
Enjoyed it. And we'll see you next time on Starting Strength Radio.